in South America, the issue is associated with, or the most unique feature in this case is going to be associated with a trench, mountain, earthquake, and volcanic activity association, all three of them. Now the question that you can go to think of being framed out of this topic is going to be actually associated with it. That is what exactly, how and where exactly is it that a trench, mountain, earthquake and volcanic activity association is going to be found? It's found only in one place, and that is going to be towards South America. Now, in order to answer that part, there is the structure that you have to make it, and what all that you need to know is, first is introduction and location. Since you are going to be talking about geography, the location is going to be significant. The second is its mechanism. That's the second part. And associated phenomena. These are going to be only two sections associated with it. So, is it that is both of these phenomena going to explain it? That is going to be followed by a conclusion. That is it that is a mechanism goes on to explain all of these features? That's what exactly is going to be our catch point in this case. To begin with, we are going to be talking about first, that is where exactly is South America. That's the place it is, and that is where you're going to be having one of these plates. Now, whenever you're going to show this type of a plate, you always go on to show with not this line. I draw it deliberately so that you can go to understand that part. This can never be any type of a boundary in general unless you are in real sorts of a hurry. That is, the boundary has to be shown in such a manner. That is the best way to show any type of a boundary. Of course, this boundary is going to be different because it is going to be a divergent margin. It's going to be a divergent part in this case. And that's the way that the movement is taking place in this region. This is how it is. Now that is going to be Nazca plate, and this is the region. That is the whole of this. This is going to be the region that we are talking of. Now, all of these are going to be known for subduction zones, and this is, if you can go to make this symbol, this type of a symbol, that is going to be simply wonderful. Very, very good. Now that goes on to mean that this is the plate, this is the place where the two plates go on to collide. That is what you have talked about, its a location. Now you can go on to write something. You can go on to talk about that this is going to be continental. It's a continental plate. That is something that is oceanic plate. You can go on to write it as oceanic plate. This is continental plate. This is the first part that we are talking about, introduction, and it's a location. That is, such type of an association is going to be found towards the western part of South America, where the Nazca plate, that is an oceanic plate, collides with South American plate, that is going to be a continental plate. And it is one of these unique, exceptional and extraordinary features that go on to be found in these zones. The first part is taken care of. Second is mechanism and associated features. What happens in this place? Now what happens is that is going to be, this is going to be one of these plates, that is we are going to be taking it in the form of a profile. That is, this is going to be taken in the form of a profile. This is the way that it is going to be taken care of. Now you can go on to write that is going to be Nazca. That's one. That is going to be South America. You must go on to label the diagrams. That is one of the ways of labeling the diagram. when you're going to be drawing it. Now, in this place, as it happens, the first is the formation of a trench. When those two plates go on to collide, that is when these two plates go on to collide, that is the South American plate and the Nazca plate going to collide, the first thing that happens is the formation of a trench. So trench forms. Now this trench is going to be known by the name of Peru-Chile trench. The name is going to be Peru. This is something that you can go to label it. Peru, Chile. That's one part. Second is, as the plates go on to subduct, as they go on to collide, they go on to lead to formation of a fold mountain. Why? Because all the sediments that used to be lying here, that is at the margin, these sediments go on to get themselves folded. So they lead to formation of a fold mountain. So fold mountain goes on to form, that goes on to run all along parallel to this zone. This is how the fold mountains go on to be, and they go on to run parallel to it. That's going to be the second part, fold mountains. The third part is associated with as the plates go on to subduct. That means they're going to plunge down. This is a process that we're going to be calling it by the name of a subduction. So as these plates go on to subduct, this subduction goes on to lead to certain degree of a friction. There is a type of a friction that goes on to take place. One plate is subducting, another plate is resisting. So these are the areas that are going to become the sign of earthquakes. This is where extension takes place. That's where extension takes place. So even if there are some cracks, these are the areas that some cracks develop because of extension. These are the areas some cracks develop because of compression. And these are the areas where some friction takes place because the plates are going to move against each other. And this is the place where some of these plates are going to get themselves detached. That is, they're going to break themselves. They're going to break themselves. That is the place where some detachment takes place. Or maybe there is some amount of exertness goes on to take place. That means they're going to get themselves exerted from beneath. So because of detachment or exertness, then an earthquake is likely to take place here. So think of it. That is, these are the zones that are going to become signs of earthquake. All of these zones going to become the sign of earthquakes. All these areas. So earthquakes take place. So trench formation takes place, fold mount formation takes place, earthquake formation takes place, and as these plates before they're going to get detached, they're going to melt, and the molten portion is being thrown upwards in the form of volcanic activity. That is going to be thrown in the form of volcanic activity. Now it is this volcano that we're going to be calling it by the name of some of these names that go on to be Ojos del Salado, that's one. Of course, Cotopaxi is going to be another one of them. That means the molten portion is what is being thrown upwards by some active volcanoes in this region. And this is what exactly combines itself to lead to formation of these four features. So, all of these four features are going to be explained where the Nazca plate goes on to collide with the South American plate. Wherever they go on to collide, this is the place that they go on to collide. The collision goes on to lead to formation of a trench. Then as the plates go on to subduct, they go on to lead to extension, some tension, extension and compression. Extension and compression go on to lead to earthquakes. Friction along this zone goes on to lead to formation of earthquakes, and as these plates go on to sink and this go on to subduct, it is this sinking and subduction that also goes on to allow volcanic activity to take place, that is going to be thrown upon by volcanic activity. And because they have been subducting, they have been colliding, the sediments that have been deposited here, they have been folded, and they have led to formation of the longest fold mountain chain in the whole of the world, extending from the southern tip of South America to the northern tip of it. This explains all of this phenomena and its conclusion also. Now you can go on to take a look at it in the form of a maybe animated form or as well. That will go on to help you a bit better. That's going to be the animated version of the whole of how is it that South America can go to form. As you can go to take a look at, this is what is going to be a trench formation. To begin with, this is what is Nazca plate that is colliding, and to play it once again, as you can go to imagine it, this is a trench formation that takes place. Now the second part is, you can go to think that is this is where subduction is going to be taking place, and all of these marked sections go on to be the symbols and signs of where earthquake will go on to take place. Now, if you're going to replay it once again and go on to think, just go on to imagine that these are the two continents that are colliding in this case and in this condition. Playing it once again, that is this is where a collision goes on to take place and the trench forms, and all of these sediments that have been here, these are the sediments that will go on to, these are the sediments that will go on to get itself folded, and that is how exactly this fold mountain formation has taken place. Now this fold mountain formation that has taken place, that goes on to imply that is going to be fold mountain to begin with first, and then you also go on to think that it's not only fold mountain, there is also going to be a volcanic mountain. So first trench formation, subduction that goes on to take place, and all along this zone you will go on to find that is some friction will go on to take place. So earthquake will go on to be generated, a fold mountain forms, and then a volcanic activity also goes on to take place. Taking another look at it, this is the magmatic arc, this is a fold mountain forms, and of course these are the different words, that is back arc, thrust belt and things like that, but then this fold mountain, on the top of a fold mountain is going to be a volcanic activity. This is another animation. As you can go to take a look at it, these are the two plates that are colliding. Now that's the line along which trench formation has taken place. That is going to be its very narrow continental shelf slope. This is going to be very narrow continental slope also. So again, playing it the same, that is that's the first thing that happens, that is a trench formation goes on to take place here. That is one of the longest trenches in the whole of the world. And as the plates go on to move inside, all along this zone happens to be earthquake zones because of the friction that goes on to take place. That's the place where friction will be taking place, so that goes on to lead to earthquakes. Now as the plates go on to move inside and plunge inside, they're going to get melted. It is this molten material that is being thrown upwards by these volcanoes, so that is going to be live volcanoes. And before that, as it is that they collided, in the process of this collision, it is these mountains and these mountains that formed. So trench formation, earthquake activity, volcanic activity, and a mountain belt, all of them going to take place simultaneously. One of these phenomena, that is geological phenomena associated with Asia, is going to be associated with island arc formation. That is, this was a question that was also going to be asked, and that has been asked. That is, there are thousands of islands off the coast of in Philippines and their adjoining regions. What are these islands and how is it that they have formed? We will be basically answering this question, but at the same time we will be taking up this entire of the issue of island arc formation, where it can go to take place. Now, all in all, with respect to island arc, what you require to know is what are they? That's one. Second is, what are their characteristics? The third is the formation of island arcs. Its formation. And this formation is going to be an example of a ocean collision. Now, if we're going to take it on a global scale, that's the way that you can go to see it, imagine it. That is one of the ways in which you can go to think and imagine it. That's where you're going to find island arcs. These are the places that you're going to find island arcs. Now we are going to be talking about what are they. Now island arcs are a group of islands. That first is going to be group of islands. One, which are arranged in arc form, that is in the form of an arc. So their convex side goes on to be facing the ocean. This is a convex side and that goes on to be facing the ocean towards this side. This is this convex side that goes on to faces this part. That is in this zone, that's one part associated with it. And there can be series of such type of islands which can go on to range in size, that can be big or that can be small. So that is also going to be part of island arc. This is also going to be part of island arc. Some of them can be, Japan can be big, it can be small as well. This is how it can go on to be. That is going to be, it's a characteristic. On one side of the island arc lies a marginal sea. This is the one side that you're going to be having marginal sea. On one side lies marginal sea. On the other side is going to be, of course, the ocean basins in this case. That is the other characteristic. Most of these island arcs are going to be active. Active, and that means they have a live volcano in this place. That is, they are going to be known for volcanic activity that keeps on taking place in the region. And it is this volcanic activity that is significant here. And it is this volcanic activity that goes on to impart a certain degree of dynamism to these island arcs. That is going to be its characteristic. That's one. How is it that these island arcs go on to form? The formation of these island arcs is going to be associated with what we go on to say it as a part of a ocean collision. If we can go on to utilize this space to explain that part, what exactly is ocean collision, we'll go on to understand it better. What exactly is happening here is, this is going to be the Asian plate. Now this Asian plate is that stands in this place, that remains here. That is going to be the Pacific plate. This Pacific plate goes on to plunge in this case. That goes on to be in the process of what we're going to say is as subduction. That is, it goes on to subduct. That's what is happening here. So the Pacific plate is subducting. Now that goes on to lead to formation of a trench. So a trench has formed all along this zone. A trench has formed. Now as it goes on to move inside, then all along these zones, volcanic activity takes place. This volcanic activity, earthquakes going to take place, and as these go on to melt, as it go on to move inside, and they go on to melt, the molten portion is being thrown upwards in the form of a volcanic activity. Now when this volcano keeps on taking place, keeps on piling, and as it keeps on piling, then in the process of its piling, it goes on to emerge above the level of water. It goes on to emerge level of water. So there is going to be one of them that emerges, second emerges, third emerges, fourth emerges, fifth emerges, and in this manner thousands of these go on to emerge above the water surface. So as they go on to emerge, we will go on to find that this is the line along which the Pacific plate, this is going to be the Pacific plate that goes on to subduct. That is going to be the Eurasian plate. That's the way that they are colliding. This is the way that they are colliding. It is along this line of collision that a Pacific plate goes on to plunge inside, and that goes on to move. The volcano is going to move upwards. That is one plate, one part. In some of these portions, for example, here there are going to be two island arcs, two lines of island arcs, one here and one here. There are going to be two of them. Now that goes on to impart even a greater number to the island arcs. So why is it that this has happened? This has happened in this region because it has happened because one of these plates, this plate had stopped subduction. That stopped subducting and that got itself locked. And in its place, there is a new subduction that has started. A new subduction that is started. That means this is going to be a new place where the subduction started. So this is how subduction started in this place. A new form started. That means a new plate kept on moving and plunged inside. Now that was largely because the energy, that is the convection current that was moving it downward, that died. This died. And a new convection current formed here. A new convection current formed here. So that went on to become active. So it led to formation of a new trench. And it is melting of this part that led to the evolution of such type of a chain, such type of a island once again. That means the process that was here, that goes on to start taking place here. And this volcano goes on to become a dead volcano. That becomes dead and this becomes active. Now you're going to be having two trenches, one and two trenches, and you're also going to be having one island arc and another island, one island arc, another island arc. So one of them is going to be dead, another is going to be active. One is going to be dead, another is going to be active in this place. So this is the way that these two island arcs have gone on to form. Now the best example of island arcs being formed in such a manner is going to be in the Pacific. Pacific Ocean is the best example because that is where you find island arcs and arcs and arcs and so on. Now that's how exactly that we went on to depict linking both of them with a profile type of a diagram. So that is going to be formation of it because of ocean collision, and that is how it has formed. These are the two diagrams. One, that is where exactly they are distributed, and the second is how is it, what exactly is the mechanism of it. Both of them are essential for you to understand this process. How is it that it goes on to take place? Another of this oceanic phenomena that is going to be pretty significant from a geological angle and from a geological viewpoint is going to be the formation of ocean ridges. So what are ocean ridges? How do they shape up? What are their characteristics? That is going to be another of this geological event taking place. It's a geological phenomena that also goes on to be taking place. So what you all need to know with respect to it is one, that is ridge formation. There's going to be ridge formation. Now when we are going to be talking about ridge formation, then indeed we require to know a lot of things about ridge formation. First is that is its characteristic. First. Second is it's going to be, now these are the areas where the ridges have formed. This is one zone that's going to be called by the name of Mid-Atlantic Ridge. And that's a symbol. That's a symbol to show that this is how exactly the movement is taking place, and these are the transform faults. This is going to be another area where the ridges have formed. This is another area that's going to be called by a different name altogether. And as you can go to find, the ridges don't go on to be continuous. They do go on to get broken by and displaced by what we're going to be calling it by the name of transform faults. And of course, you do going to be having a system of ridges here as well. That is, in the whole of the world, you do go on to find a system of such type of ridges. Now, you can go on to take a look at it from this world map also. That is, we have made it, but you can go on to take a look at it Now, that's one part. What are its characteristics? Now, when you're going to be talking about its characteristics, these characteristics are going to be very, very specific here. One its characteristic is that it is about 4,000 to 4,000 meters high from the surface. Second is that it is generally symmetrical. Third is that it goes on to be having a rift valley on the top. The fourth is going to be traversed by transform faults. Fifth is it goes on to be having a volcanic activity, known for volcanic activity. And the sixth is it can also be a region of earthquake. These are its characteristics. So, if we can go to pick it up in such a manner, that is, this is how exactly this region is going to look like. Now, as you're going to find it, that's the way, these are the ridges. That's how they're going to look like. And when we're going to say that's the way that's going to look like, that is, they are going to be high. This is going to be something like some 4,000 meters. They can go to be as high from the nearby regions by 4,000 meters. They're going to be having a rift valley on the top. That's a rift valley on the top. They're going to be traversed by a transform fault all along. They don't go to move in a straight line. They have been traversed by a series of transform faults. They are symmetrical. They are going to be symmetrical. They're going to be having a rift valley. They are known for volcanic activity. It is here that the volcanic activity takes place. That's the place where a constant volcanic activity takes place here. And their formation is such that it does lead to formation of a crack and a rift valley, and that goes on to become the cause of earthquakes. So see its mechanism, what happens in this case here. Now that is how the movement takes place. This is the way that the movement takes place. That's the way. How exactly is it that the two parts go on to move apart? They move apart because of a variety of reasons here. That's how this movement takes place, from below to the top, from below to the top. Now, because of the development of a crack, just beneath it, this crack, as this crack develops, so first see that a crack develops over the top. This crack lowers the pressure. Because of the crack, the pressure is lowered. Lowering of the pressure causes melting point to be lowered. The lowering of the melting point causes melting of a rock called as peridotite, and consequently this becomes a cause for volcanic activity. That's the reason. There is the pressure, that is, crack has formed. First a crack has formed, and this crack may have formed. We can go on to take it a bit forward. There is a divergence goes on to take place. In this, a divergence takes place, and because the divergence takes place, that leads to formation of a crack. Beneath the crack, the pressure is lowered. Now this is the place where the pressure has been lowered. That's the place, pressure has been lowered, and all of these rocks that may have been here, their melting point is reduced. The reduction of this melting point causes these rocks to melt at a temperature at which they are. It causes them to melt in this place at which they are. It is this melting, the molten portion goes on to become buoyant. It goes on to occupy a higher volume. It goes on to become buoyant, and consequently it rises. It rises along all of these cracks. As it goes on to rise along this crack, it goes on to lead to formation of a layer of magma on the top, of layer of lava on the top. That's one part. Now understand this in another way. That is, as it is that divergence takes place. Such type of a divergence has taken place as it is in this case. This divergence causes two of these plates to be cracked apart, and when they go on to move apart, then the central portion goes on to sink and subside. All along this sinking, all along this place, while it goes on to sink, all along these zones that undergoes friction. This is a zone that undergoes friction, and as it undergoes friction, it goes on to become the reason for earthquakes. These earthquakes are not going to be very prominent, but then an earthquake does go to take place all along this zone. So imagine how many things can go to happen. That is first, of course, a crack, a rift valley on the top. Second is a volcanic activity. Third is an earthquake. That is this is a rift valley traversed by transform faults. They have been traversed by transform faults, volcanic activity and earthquake. This is what exactly is going to be the normal process and the procedure that goes on to take place wherever such type of a divergence takes place. Now you can go on to take a better look at it by taking a look at its animated version. Now this is going to be another of this geological phenomena, but that is taking place in the continent. That was, we talked about the ridge formation, that is sea floor spreading, that was on the oceans, and that is going to be on the continent. What you all need to know about it is where exactly is it that the African Rift Valley is located, which is going to be known by the name of EARV, East African Rift Valley. What are its features? We have talked about the features like step faulting, earthquake frequency, active volcanoes, and these are Ertale, Dallapilla, Oidunya, Longai, Nirongogo, volcanic mountains, and then the two features, that is East African Rift Valley and Western Rift Valley, two of them, beginning with its location. That is, if we can go on to draw a map of Africa, then the East African Rift Valley goes on to extend all the way from here up to Lake Malawi. That is going to be from Dead Sea. It is going to be from Dead Sea, and that is going to be up till Lake Malawi. That is going to be its location in this case. Of course, there is the extension arm goes on to go in this manner as well. Here also, that is one of these arms of extension. But that's how exactly East African Rift Valley is located. East African Rift Valley is the largest manifestation of a fault over the surface of the earth. It also goes on to be having one of the highest frequencies of earthquakes that are going to be found along this place. It is also going to be one of those type of places in this region that go on to be associated with type of volcanic activity that is not going to be experienced anywhere in the whole of the world. Now that is going to be the place associated with it. That's one part. Talking about its features, one of them is going to be step faulting. Now what is happening in this region is that before we go into picking up its features, talking about its formation, how is it that it went on to form was, that is the whole of this region was, this is where exactly is a place called as Afar. Now it is along this region that the whole of Africa is getting itself uplifted. It is along this zone. So as it goes into be getting itself uplifted, it leads to development of a crack. That's the way that the crack goes on to move. That is how the crack is moving. And when this crack goes on to move in such a manner, that's the phenomena that is taking place in this zone. That means the whole of this region has got itself uplifted, and this has got uplifted because it goes on to lie over a mantle plume. It goes on to lie over a mantle plume. So as it goes on to affect the whole of Africa, imagine this is going to be the African plate. As this mantle plume goes on to move upward, what it goes on to do is that it leads to the formation of a dome. A dome forms in this place. Thereafter, this dome goes on to get itself cracked. That is how it develops a crack. Now imagine this crack, the whole of this place, this crack is going to be step faulting. That means if you can go to see that, see the whole of this portion in some detail, that is, you're going to see some of this portion in detail, you will going to find that's the way that the faults go on to develop in this zone. That is how this fault has developed in this zone. This is how it looks like. So this portion is getting itself extended. That is getting itself extended. So because it lies over a mantle plume, first a dome goes into form. Now the dome is not able to sustain itself and goes to develop some cracks. So these are the type of cracks. Now all of these cracks go on to sink. They're going to get deepened, and when they're going to get deepened, then the whole of this area goes on to below the level of the sea, and then an arm of sea goes on to intrude here. Now this is what has happened with Red Sea. This is what has happened with Red Sea in this zone, in this region. That's what we are talking about in this case. That's one segment. That's the condition. And both of these areas are elevated. They are going to be elevated plateaus of sorts. They are going to be elevated mountains of sorts. So both of these regions go on to get themselves elevated in a manner. They have got themselves elevated in a manner as to allow this to happen. Now, when the whole of this region goes on to develop a crack and it goes on to melt, that is, because of this mantle plume, the entire of this region goes on to melt. The whole of this portion have undergone melting. Then this goes on to become the site of volcanic activity. Later on, the whole of this region goes on to become the site of volcanic activity. And earthquakes as well. And why is it that this volcanic activity and earthquake will going to take place? Think of it. As each one of these blocks go on to sink, as each one of these blocks go on to sink here, each of these blocks go on to sink, each of these blocks go on to sink, then the friction that goes on to take place, that goes on to become the site of earthquake activity. Now through these cracks, all of these cracks go on to become passageways. These are the cracks. These are the cracks that go on to become passageways. They are the one that go on to become passageway through which some eruptions take place. It is through these cracks that some eruptions take place. We are going to be talking about this eruption. That is, eruption will going to take place in this region, and that will going to become the site of volcanic activity also. So as we said, that is going to be a step faulting. This is going to be a step fault. Earthquake frequency, we have talked about, that is going to be earthquake. Melting will going to lead to formation of volcanoes and a volcanic mountain. Now, when that is going to be taking place and is happening, now this is the place that we're going to find one of these volcanic cones. That is going to be Kilimanjaro. That's one. Mount Kenya and Kilimanjaro, these are going to be the two of them that have developed in this region. That's a single volcanic cone. And this is different from rest of the places in the world because it's a single volcanic cone. That means it's a massive, symmetrical, remarkably symmetrical cone where the top of this portion goes on to be, despite being on equator, it is always going to be snow laden. It's always going to be snow laden. Of course, it is a dead volcano right now, but some time back, this is what used to. This was the one that actually went on to form because of this volcanic activity. That has been its condition. That has been its case here. That is how exactly that we going to know of this region. So we talked about these features, how exactly it went on to form, and how is it that it has been associated with its features. Now there are going to be some exceptional features associated with it. The first is that the number of tremors that go on to emerge out in this region, these tremors are going to be the maximum anywhere in the whole of the world. It's like there is almost every 10-15 days you're going to find some or the other type of a tremor developing in this region. That's number one. And second is when you're going to pick up these type of volcanoes, then one of these volcanoes, Dunya Lengai, this is going to be, its lava is going to be so fluid that it goes on to flow almost like that of water. It's going to be called by the name of cold volcano. It's going to be called by the name of cold volcano. That is going to be the name given to it, cold volcano. And it actually goes on to flow like that of almost like that of water. That is going to be in Dunya Lengai. And Nirongogo is going to be one of them that is going to be associated with a lava lake. It is going to be lava lake. Now that is going to be its feature, and that's going to be divided into two portions, Eastern Rift Valley and Western Rift Valley. It is along the East African Rift Valley that Africa in future is going to be split into two separate continents, because as you have seen it, that the divergence keeps on going, and because of this divergence, this is what is going to happen. The EARV, that is the East African Rift Valley, consists of two main branches. We're going to talk of the East African Rift Valley includes the main Ethiopian, that is the two main branches, main Ethiopian Rift running from Afar, the one that we're going to talk about, that is Afar Depression, and then south has the Kenyan Rift. The East African Rift Valley comprises Danakil Depression and its volcanoes, all the volcanoes of Danakil Depression. While the Western Rift Valley includes the Albertine Rift, continuing south in the Lake of Malawi, and there are many crater lakes in the Albertine Rift. The East African zone includes a number of active as well as dormant volcanoes. Some of them going to include Mount Kilimanjaro, Mount Kenya, Mount Nirongogo, and Mount Meru, as well as the crater highlands in Tanzania. Most of these mountains lie outside the Rift Valley, but it was a process associated with the East African Rift Valley that actually created them. When we're going to say that it was a process that was actually responsible for creating them, that means there were certain type of cracks that led to its formation. The whole of East African Rift Valley is going to be known for some of these active volcanoes that go to include Ertabe, Dallafilla, Oidonia Longai. Ertale is the only permanent active volcano in the whole of Africa. That's one. And Oidonia Longai is the coldest lava eruption in the whole of the world, where it goes on to be having a natrocarbonate volcano. It's the only example of a natrocarbonate volcano in the whole of the world, where the magma contains zero silica, making the flow completely like that of water. also in this case. This like, and then there is going to be another of this lava lake that we have talked about, Nirongogo, and that is going to be in the Tanzanian Zaire border. It's the largest lake filled with lava in the whole of the world. Of course, there are going to be a good number of boiling water lakes in East African Rift Valley also. The East African Rift Valley is a seismically active rift zone on the earth. It is along this East African Rift Valley, that is Africa is going to be split, and we have talked about that. It goes on to be one of these largest of these regions that goes on to have a variety of type of fault lakes in the world that goes on to lie in a form of a line, all along in the form of a line. That is, other than Lake Victoria, it is going to be Lake Assal, Lake Tana, Lake Albert, Turkana, Edward, all of them up till Lake Malawi. Now that is going to be the location of East African Rift Valley. As you can go to see, this is a diagram where exactly East African Valley lies, and that is going to be the extension of it. Now this extension that you're going to find it, that goes on to run all the way from the Dead Sea, that is going to be north, that's somewhere here, up till Lake Malawi, that is going to be towards the southern portion of it. And it is between these that you're going to find a good number of active volcanoes, that is Oi, Donia, Longai. Then that's the place that you're going to find Erta Abe. These are the places. And it's along this Rift Valley, that is along all of it, Rift Valley, that Africa is going to, it's going to die, it's going to get itself fragmented also. It is along this zone. Now this is another of this diagram that you're going to see it, that is, we said that is its formation of it is associated with a mantle plume. This is the mantle plume through which it goes on to form. And when it goes on to form, and when Africa goes on to lie over it, then it has led to formation of a three-pronged crack. One of these cracks goes on to move towards Jordan, that is towards Dead Sea. Another that is going to be, as you can go to see, that is going to be Gulf of Aden Rift, and of course the other is going to be Red Sea Rift. So it is going to be a three-pronged crack that has evolved in this region above this rising plume. Now that is a sign of so many of these type of cracks and parallel faults that have gone to form in this region. We're going to be talking about step faulting. Now that is going to be step fault. One of these step faults, there are going to be multiple fractures that are going to be found. It is going to be along one of these multiple fractures that the volcanic activity that took place that led to formation of Mount Kilimanjaro, and that goes on to become the main African Rift Valley. You do going to be having this central block that is going to be Horst, and again going to be another of this component of Rift Valley, that is going to be the east and the west, that we have both of them that we have talked about, and also the multiple fracturing that you're going to see it here. There is so many of these step faults that have evolved in the region. The East African Valley is one of them. EARV is one of this, where in future this is going to be one of these cracks that went on to develop. That's one part, that is Red Sea, and then going to be the Aden part, that is going to be the second one. This is going to be another one, and that's the way that the Rift Valley is going to move ahead. That is how this Rift Valley will go on to be moving ahead. That's the way. And when the East African Rift Valley goes on to develop a crack, it is along this line. It is along this line that the whole of Africa will go on to break away and go on to move in two different directions. Talking about the geological phenomena, one of the most recent of these geological phenomena has been COSGROVE volcanic chain. As we said, that is going to be one of the most recent one of them, because it has been recently found, not exactly that the activity has been recent. What we all need to know about COSGROVE is that is its location, where exactly it is, its features, its formation, and fourth, some evidences. Effectively, even if we go on to begin with location, we are always going to be talking about its history and other places. That means if there is any other place where such type of a volcanic chain goes on to exist. It does going to exist, and that is going to be in the Pacific. If we can go on to pick up this case from now, that is going to be in the Pacific, and you're going to find that there is a line of volcano that goes on to move in such a manner. There's another one that goes on to move in such a manner, and there is a third one that also goes on to move in such a manner. Now that's how it is going to be placed, of course, hand drawn, so consequently it cannot go on to be put to scale. This is going to be called as Emperor Sea Mount chain. Now what has happened in this case is that it goes on to comprise of one small volcano, another, and then a series of it that is going to be ending here in the south are still Hawaii, where it is an active volcano. That's going to be called as Austral Marshall Gilbert. This is going to be called by another name, that is Line Tuamotu. All of them going to be having an active volcano towards its south. Now this means that goes on to be having a pattern in this case. That is, in this case also there is going to be an active volcano here. Here also there is going to be an active volcano. In this place also there is going to be an active volcano. That's also one of these places. So you're going to be having a series of dead volcanoes, and then you're going to be having an active volcano going to be at in the south. That's another part associated with it. Now, understand it. All of these have been in the oceans here. This is an example of volcanic line. All of these have been oceans here. COSGROVE volcanic chain is the only example in the whole of a world of a volcanic chain that has developed on the continents. So, if we can go to pick up Australia, if we are going to picking it up, we're going to observe that sometime back in Australia, what happened was there was one volcanic cone that developed on the land, another, and so on. And right now, this is one of these places that is going to be active. That is, it has the potential to be active. The entire line of this dormant volcano, dead volcano, that is going to be, all of it is going to be dead. This is going to be dead volcano. That's the only one which has the potential to be active in this region. And that is going to be, the last of it is going to be in this place that's going to be called by the name of COSGROVE. That's going to be called by the name COSGROVE. And that's why it is going to be called by the name of COSGROVE volcanic chain. Now, what had happened in this place was, that is why exactly that this one evolved or this one evolved, is that both of them going to be lying on a plate. And Australia was, this was going to be one of these first volcanoes that took place. That means that is where beneath, that's the place where Australia was. That means there is a mantle plume. That's the place that's going to be a mantle plume. So it goes on to lead to formation of one volcano. Now, as it goes on to move forward, this moves forward, it goes on to lead to formation of, that is, if it goes on to move in this direction, then that goes on to move backward, and as it goes on to move backward, it goes on to leave one dead volcano, then another comes up, then another comes up, then another comes up, then another comes up. Now, that is the way that a series of cones go on to keep on developing as they go on to move forward. That means it is in this case that is their movement forward or backward in any manner, it goes on to create one cone, and as it goes on to move forward, it goes on to allow the first one to be dead and a second one comes up. Then again as you move forward, it goes on to allow the second one to become dead and the third one comes up. That's what happened there. So this plate was moving in such a direction. This is going to be indicative of the plate direction. That was moving in such a direction, and that's where exactly it went on to change its direction. But that has been ocean. In Australia, that has been the case. That is, this was the first place where such type of volcano formed. And as we said, that is going void. It was one of the first cases. So Australia moved in certain direction. So it is going to be here. Now, as Australia goes into move forward, it's still northward. It will go on to become even southward. The active zone will go on to become southward. Now, this is where exactly an active zone has been identified. And because of this name of COSGROVE, it has been called by the name of a COSGROVE chain. So as we're going to say, that is going to be formed. That's the way that it went on to form. Features are that it goes on to be having a signs of volcanic cone on the mainland of Australia. Now, from that perspective, Australia is the only continent in the whole of the world where such type of a volcanic chain has evolved. It's the only continent in the whole of the world to have allowed the evolution of such type of a volcanic cone. That is one. That's going to be one of these features. Second feature is going to be, of course, associated with along Tasmania, this place, the whole of the region is getting itself elevated. Along this zone, the entire of the region is getting itself elevated. And because this region is going to be getting itself elevated in this place, in here, consequently, that's the place where it is likely to get burst up. That means that's the place which will go on to get burst up also. And when this bursting up goes on to take place, then of course that will go on to become an active volcano. And we're going to know that because the temperature of the surface in this place is going to be very, very high. And that is one of the ways by way of which we're going to know that there are chances of the fact that there is an active volcano picking up in the region. That is going to be formation. Evidences are, of course, these are the one that go on to be evidences associated with it. And of course, the other evidence is that in around Adelaide, there are going to be frequent tremors that we're going to experience here. A good number of tremors going to be getting itself experienced all along this zone. This is the place where such type of tremors and small tremors keep on taking place. That means some inactivity, some instability is always going to be existing in the region. So, with respect to COSGROVE, that's the location that we have talked about in Australia. The features are going to be, that is a series of dead cones all along this zone. Formation is, this is the way that it goes on to form. It's the only example of formation that has taken place on the continents. Evidences are, of course, there is a dead cones that going to found here. This is going to be another evidence that it has happened in the past. And then, of course, the evidence is, other evidence is going to be, second evidence is going to be frequent tremors in Adelaide. And the last of this evidence, that is in just towards the north of Tasmania, the temperatures, that is what we're going to be calling jacket temperatures, are going to be very high. That means that's the place where it is likely to burst up and goes on to erupt. Now, taking a look at this map of Australia, as you can go to find it, that is it begins all the way from Hillsborough, Peak Range, Springsore, Buckland, Broek, then Begaro Hills. That's where exactly is COSGROVE, and that is going to be Tasmania. That's towards the north of Tasmania, all along, as you're going to find it, all along this zone. You're going to find a series of dead volcanoes and a series of dead cones. Now, of course, these are dead cones, and it is very evident that these are dead cones. One can go to find it on the surface. Now, that means this was the first one to have formed, this was the second one, this was the third one, fourth one, and so on and so forth, as Australia moved towards the north. As it keeps on moving towards the north, then there will be another of this cone that will go on to keep on moving towards its south. Now, that is what exactly is called as COSGROVE volcanic chain. This animation will go on to help you to understand it even in a better manner. That is, it goes on to, any of this plate that goes on to lie over a heat, there is a mantle plume. It allows the heat to rise. This rising heat ultimately goes into break through the surface, that means rises onto the surface. And as it goes on to rise on the surface, it goes on to lead to formation of a cone. And imagine this plate is moving. So the cone goes on to develop in this place. Erupted lava builds mountains that emerge as islands, while the lithospheric plate keeps on moving. So as it goes on to move, then the previously formed lava goes on to get itself detached from the source. And what happens is a new cone goes on to form. And then again it goes on to move and a new cone goes on to form. And again it goes on to move, a new cone goes on to form. And so on and so forth. Now, this is the general mechanism. This is what exactly happened with Australia as well. That means what happened was that as Australia was moving northward, it was beneath such type of a mantle plume, then it led to the evolution of one cone, then the second cone, then the third, fourth, and that's where exactly it is right now. This is the southernmost portion of Australia, and that's going to be just towards the north of Tasmania in this place, and that goes on to be the southernmost part. Consequently, all the way from north to south, it goes on to form a series of volcanic cones that we have called it by the name of COSGROVE volcanic chain. One of these topics which happens to be part of a question also that has been asked in 2018, and that is part of geological phenomena, geological events, is mantle plume. Effectively, even if you're going to think from any dimension possible and from the perspective of civil services examination, it won't be that there can be too many dimensions of this topic that can be asked. And one of these topics that was asked, one of the questions that was framed, one of the ways in which it was going to be asked was simple. First was, what is mantle plume? That is, what exactly is mantle plume? Second is the mechanism of it. The third is that is impact on plate tectonics. Now, this impact goes on to include first, that is on epeirogenic movement. Second, on splitting of the continents. Third is going to be in form of volcanic chains. And fourth, of course, is going to be, that is volcanic activity. Beginning with the first part, mantle plume is effectively, it's a column of a magma that originates somewhere on the core mantle boundary. That is, if you're going to consider this to be part of the whole of the earth, that is going to be the crustal portion, that is going to be the this is inner core, that's outer core. Then somewhere from this part, somewhere from this portion, there is a column of magma that goes on to rise on the top. Now, this rise that goes on to take place, that is it goes on to be occupying a circumference of about 200 square kilometer and rises at a rate of something like some 10 meter per year. Now, none of these things are determinate. Even if it going to say it so, none of these things are determinate at all. Why exactly it is that there are going to be some fixed spots from where it happens to rise is something related to some type of meteoritic impacts that may have taken some time back. So it's possible that is millions of years back when there was a meteoritic impact. Then in the course of this meteoritic impact, the meteorite hit it and it kept on sinking beneath the earth. And that is the portion up till which it kept on sinking. And as it kept on sinking, this inner core, outer core, from this outer core, it almost created something like a hole of sorts. And it is from this portion that the hole that has been created that spews out in the form of a volcanic activity. Now, that is going to be one of these possibilities and one of the not mechanism, one of the possibilities, and we are talking about one of the possibilities. We are not saying with certainty that this is what happens here. In any case, the outer core is warm enough, it is energetic enough to such an extent that it is energetic enough to such an extent that it must go on to convect, it must go on to release its energy. And in the course of releasing its energy, it keeps on looking for some of the places here and there by way of which it can go on to release its energy. And one of these places through which it can go on to do it is going to be called as, that mechanism is called as mantle plume, and the surface over which it goes on to take place is going to be called by the name of hotspot. So that is going to be a chimney of magma that goes on to rise from that place. That is going to be what exactly it is and what it is mechanism. Its impact is going to be, one of this impact is going to be on a epirogenic movement. Epirogenic movement is a continental building movement. And one such type of movement that has taken place is going to be that is the place that it has taken place. Here, this is the region. There is a mantle plume beneath, and what it has done is that it has uplifted the whole of this section. It has uplifted the whole of this section. The entire of this region has got itself uplifted. And when it has uplifted, it has created this crack in three different directions. In three different directions, it has created a crack. So one is goes on to go towards in the African Valley, another is going to be towards Red Sea, and the third is going to be towards the Gulf of Aden. It goes on to be in three different type of directions. So what it has done here is that it has led to formation of a dome. That is, if we can go on to take this diagram in a different manner, what it has done is that it has led to the formation of a dome. This is what we're going to be calling it by the name of updoming. And when such type of a dome has been created, then that has led to development of some cracks. This is the type of a crack that has evolved. And it is along this crack that Africa is getting itself dismembered into different directions. So first of all, it was this was going to be a surface, this was going to be a surface, and beneath this surface a mantle plume took place. The net result was that the magma moving constantly upward went on to updome it, and there was a vertical movement. It is this vertical movement that we go on to call it by the name of epirogenic movement. So every continent goes on to suffer from this type of an unmistakable evidence. That is, even in case of North America, there is a mantle plume beneath Yellowstone National Park, so it is getting elevated. The Colorado Plateau got itself elevated. Same as the Deccan Plateau got itself elevated, and same has been the case. That is the place where Lake Baikal is right now, that is also going to be possibly lying beneath a mantle plume, and that is also going to be getting itself elevated. That has been one case. That is going to be the first part, that is a epirogenic movement, and then the splitting of these continents. Along this line, what will happen in the future will be, that is along this line, the whole of Africa will go on to get itself broken. That's what exactly will go on to be shape of it, shape of this continent, and the Red Sea will go on to get itself completely elevated, and it is going to be getting itself extended. So this will go on to get itself extended. This will move away from each other. Now that is going to be splitting of these continents. India also went on to split itself in a similar type of a manner. That is the second part. The third is, if it goes on to be beneath any moving plate, it will go on to lead to formation of volcanic chains. So what happened was, that is, this is where Africa has been. Now, Africa had been under one of those type of mantle plumes. So what happened was, it led to the evolution of a volcanic cone here, there, everywhere, all along this place. Now this, that is the present one, this is going to be the present position. That goes into the present position. So all along you're going to find a series of volcanic cones that have developed. This is going to be called by the name of COSGROVE. Now, and Africa was moving, it was moving northward. So as it was moving northward, then kept moving northward, kept on moving northward, and this was the first one that created, then that was the second one, the third one, fourth one. Now this, the fifth one, is going to be the present one that is going to be here. Now you can go to understand it. That is, if such type of a mantle plume goes on to develop beneath the ocean basin, what will going to happen? What will going to happen is that this is going to be the oceanic plate. That is going to be oceanic plate. So maybe that this is the place where the first, that is the present volcanic activity that has taken place. And supposing that this plate has been moving in this direction, this is the way that it has been moving, then it will go on to create 1, 2, 3, 4. That was the first one, this was the second one, this was the third one, this was the fourth one. So as the plate moved, then the first was, this was what was one volcanic cone that was created, and that moved with the plate. Subsequently, one was behind, then another was behind, then another was behind. And it is in such a manner that a volcanic chain has established. So we have COSGROVE volcanic chain, and in a similar manner you're going to be having Emperor Sea Mount chain. Emperor Sea Mount chain. Also Austral Marshall Gilbert chain. Austral Gilbert. There is going to be another aspect associated with plate tectonics, and the last is going to be volcanic activity. If you can go on to take into account the position of North America, the position of North America, you're going to find this is one of these places that is going to be getting itself elevated. That is Yellowstone. This is a Yellowstone. And that is one of those places that is getting itself elevated. It's getting itself elevated. And as it is getting itself elevated, the whole of this crustal region beneath is getting itself thinned. What is happening beneath is, that is, if this is going to be the place, then the whole of this crustal region is getting itself thinned. It has thinned considerably. And it may happen that it goes into thin completely to be completely worn down, and it will go on to lead to a massive volcanic eruption. This will go on to lead to the evolution of a massive volcanic eruption in this place. Similar type of volcanic eruptions go on to take place in Iceland. A similar type of volcanic eruption has taken place in Hawaii. It keeps on taking place, and this is going to be another of this place where it is likely to take place. Now, that is going to be its impact on plate tectonics, on epeirogenic movement, on splitting of the continents and movement apart, volcanic chain creation. Volcanic chain can go to be both on the continent, that is COSGROVE, and on ocean, that is going to be Emperor Sea Mount, and volcanic activity that is going to be even on in Africa also. That is in all of these places that is going to be on a hot spot. In all of those places, the volcanic activity keeps on taking place, and the best example is the volcanic activity associated with this mantle plume. Now you can go on to see the whole of this in a form of animation. As we say, these mantle plumes are isolated, long, slender columns of hot rock that originate deep inside the Earth's mantle. They are thought to have diameters of about 100 to 240 kilometers and rise slowly at a rate of about, no one knows it, but then it's speculated as something like some 2 meters to 10 meters per year. These hotspots, which channel heat to the surface from deep within the mantle, are fixed spots and erupt periodically on the surface. Hotspot plumes of magma are not uniform. They differ in their chemistry, suggesting that they come from different type of depths. Some of them may go on to comprise of high amount of alkalinity, some of them high amount of calcium carbonate, And accordingly, they can go to be called as calc alkaline thoracic basalt. They can be called by the name of quartz normative thoracic basalt, etc. They last for about 100 million years or so, and there are going to be no less than something like some 122 hotspots that have been active in the past 10 million years or so. One of these, the way that is the movement goes on to be taking place is shown to you in this animation. As you can go to take a look at it on the screen. This is the core mantle boundary. That is how exactly there is a rising plume. Now this rising plume goes on to move upward, and then it goes on to reach its head. Now in the second one of them, as you're going to find it, that is, it goes on to move, and it goes on to moving in the form of a plume. And as it goes on to come onto the surface, it is able to spew of a volcanic activity on the surface. It may also happen that in this case, the plume that is going to be rising, it will going to leave a trail of volcanic activity. That means one behind the other, behind the other. There are numerous such type of mantle plumes. One that you're going to find it here, that is going to be the place where your cursor is going to be, that is going to be Hawaii. That's one part. And then you go on to find another one of them that is going to be in McDonald Seamount, then Bifani Islands. Of course, you're going to find it beneath Iceland is going to be one of them. Azores is going to be another one of them. Canary is going to be another of them. And Tristan da Cunha, these are some of the names that will go on to keep on hearing. Galapagos is going to be another one of them in this case. And Easter Islands are part of it. So there are going to be good number of mantle plumes that exist onto the surface. This is one of those dimensions diagram, 3-dimensional diagram that have been simulated to help you understand how is it that a mantle plume can go on to look like. Now, this is the mantle plume. You're going to take a look at it once again. That is the mantle plume, and as it is goes on to rise, it goes on to come onto the surface and then goes on to get itself spread apart in this zone. That's how exactly a 3D model has been prepared for a mantle plume. One of the impact that mantle plume goes on to have is going to be on the movement of the plate. The mantle plumes are one of the mechanisms for movement of plates. As the mantle plumes diverge beneath the plates, they exert an extensional force. The extensional force causes the plates to be stretched and finally be ruptured. The convection currents thus carry the plates with themselves. This was the way that Africa got ruptured, and it's moving in two different directions along the East African Rift Valley. Africa was located over a rising plume. As you can go to see it from the mark where the cursor is right now. That is, it was located over a mantle plume. That is, there was a hot column of magma that was coming from below, and as it was going to be rising, these were the plates. So the first thing that it did was that it went on to dome the plates, and then thereafter in the second stage it allowed to develop some cracks. So some cracks came up in the region. As these cracks came up in the region, then these cracks were moving in 3 different directions. One, that was second, there was third. Of course, at that point of a time, there was another direction as well. But then this is how exactly any type of a crack goes on to develop. So the first case in this case was an updoming. The whole portion went on to get itself domed, and then unable to bear the elastic limit of the rocks, it ultimately ruptured. It was in this rupturing that it developed these 3 cracks. Now, one of these crack is going to be Gulf of Aden. The other is going to be the Red Sea. And the third is going to be that of the East African Rift Valley. This was the case. That is, one of them was the East African Rift Valley. This has been the East African Rift Valley all along this place, in this zone, in this place. Then you go on to find that was going to Gulf of Aden, and the third was going to be the place where you do go on to find the Red Sea. That is going to be Red Sea. Red Sea goes on to extend all the way towards its top. And it is along this line. This is what we're going to be calling it as a Afar region. And that's where exactly there are going to be 3 places that go on. That's the place where which is getting itself elevated. And that goes on to mark one of these type of junctions, and this is going to be the third arm of this crack. The third arm of this crack goes on to be going all the way to Malawi, all the way to Malawi. Now, this is going to be activated to such an extent after some time that Africa is likely to split along this line. And it is in all probability showing signs of splitting. It has already split and it is going to be showing signs of such type of splitting as well. Now, this goes on to show the development and evolution of a rift valley. That is, these are the cracks. These are completely new cracks that have evolved in Africa. That means it is going to be along this line that Africa is going to be getting itself split. That is, the Great Valley that will go on to run through East African Rift Valley will go on to allow it to be completely ruptured. This is a live picture picked up from Africa, and see the way that the cracks have developed in this region. Now, that is going to be one of these cracks, and deep beneath it, these are type of spots. These are the type of spots from where some smoke and other things have started coming up onto the surface. And there are going to be only some of them, these type of spots. And take a look at these type of spots, the type of a crack that is going to be developing all the way. And that is a line along which Africa will go on to get itself completely ruptured. It's a site to visit, it's a site to see, and it's a sight to behold as well, because you know that you, after some time, you will be walking on a different continent, because this is the place where two of these continents will go on to get themselves ruptured, and they'll go on to get themselves pulled apart as well. That's going to be one of those type of signs, and that is where exactly that is likely to happen, and that is the type of a shape that Africa will ultimately go on to acquire. It will go on to lead to creation of a new ocean. It will go on to lead to creation of a new continent as well in this case. Effect has taken place that has been on the movement of the plates. And how is it that it goes into rupture? On the continent, the impact that is going to be that as the plates reach the lithosphere, it spreads laterally during the superficial zones of the earth and moving in this manner in direction of a radial flow. This causes a pyrogenic movement. The center of our triangle in Ethiopia is one side of plume that flowed upward and outward, carrying the Arabian, African, and Somalian plate, and moved away from the center of triangle. They are also probably capable of causing surface uplift over something like some 100 kilometers across, both by the direct effects of the heating of the lithosphere and by associated thickening of the crust. On the continents, mantle plumes have probably been responsible also for, that is, the second impact is for generating voluminous and extensive accumulation of basalt flow, such as the one that has taken place in the Karoo series in Africa. And the best example in this case is going to be Deccan basalts. Now, Deccan basalts are going to be the prime example, because the amount of magmatic activity that took place while India was moving over the reunion hotspot has been unparalleled in the history of the earth. So much amount of magma ultimately came out onto the surface. But some historical aspects apart. On the continents, the manifestation of the mantle plume is best seen in two places. One of them is going to be over Yellowstone, that's one, and the second is going to be over COSGROVE volcanic chain in Australia. Well, this is an example of what is happening beneath Yellowstone National Park. And as you can go on to find it, that's the place from where volcanic activity is taking place. These are all going to be Yellowstone National Park regions. And that is going to be, these are going to be some of the manifestations of such type of eruptions that have taken place. Formation of a Grand Canyon, the Grand Prismatic Compass in the region, and then the geysers that happen to follow soon thereafter. Now, these are the Yellowstone hotspots that took place over some time. That means that indicates some amount of a movement of the North American plate over a hotspot. So, this is the direction. The way that is moving is going to be the present direction, so that that is the modern place. This is going to be the modern place, the one that we showed it just now. The whole of this region is the one that is going to be affected by such type of movements, and the area concerned is going to be the ashfall zone. That means over such a long area that has taken place. It also has led to the evolution of a Yellowstone caldera on the top, and it is going to be all along this Yellowstone caldera that you going to find a lot of geysers, a lot of fumaroles in this place. And the region is going to be essentially known for geysers and fumaroles. This is going to be one of those type of one type of a geyser that goes on to be onto the surface, hot water geyser on the surface. And the place is getting itself thinned, and after some time it will go on to get itself broken, ruptured apart, and you must have seen it. This was what was the theme of one of the movies also, that was 2012. That showed that his volcanic activity can go on to take place. This is going to be made of boiling water, and these are the areas which are going to be prone to such type of eruptions. That is the way that the eruptions are going to be taking place. One of them is going to be definitely Yellowstone National Park. The second is a COSGROVE volcanic chain in Australia. As you can go to see it, that is COSGROVE volcanic chain in Australia. This was the first of the cone that was opened up by a mantle plume, first of it. And then as Australia kept on moving northward, then volcanic activity shifted itself southward. That is, shifted itself southward, kept on shifting itself southward to occupy a present one that is in Australia, that is going to be called by the name of COSGROVE. And accordingly, it is going to be called by the name of COSGROVE volcanic chain. Now, south of it, further south of it, just going to be near to Tasmania. Now, that is one of these places where the surface is getting itself heated, and from this heated region, the whole of this region will go on to get itself ruptured, and the ruptured portion will go on to lead to volcanic activity. What are the evidences that is going to be taking place? The evidence in this case is that the whole of the region where the present mantle plume is, it has a very high temperature. That's one. And it goes on to show every sign of the fact that that's a place that is going to melt. And of course, the second evidence in this case is that Adelaide goes on to keep on having a large number of earthquake tremors. It is these type of tremors that go on to show that the earth in this case is not going to be stable at all. On the oceans, mantle plume create lines of large volcanoes, such as the one that you're going to find in Hawaiian Island, if the overlying plate is moving with respect to the plume. As the oceanic plate moves over a hot spot, that means that the hot spot going to emerge, and as the oceanic plate goes on to move over this hot spot, successive eruptions, the first eruption will go on to lead to formation of one volcanic cone. And successive eruptions that go on to take place with the movement of the plate, that go on to lead to formation of series of peaks of seamount on the moving crustal plate. It is in such a manner that the youngest peak is above the hot plume, and the seamounts increase in age as the distance from the spot increases. It is in this manner that inactive cones are linearly arranged, and that also goes on to show the direction of plate movement, but the end is still near where the hot spot of the continent is active, and that still goes on to be one of those places where the volcanic activity keeps on taking place. Now, this is exactly the case of Hawaii. Hawaiian Islands are going to be one of those portions and one of those regions which go on to show so much amount of activity, and the volcano is going to be still active in that place. But subsequent to that, all of that has been before, that doesn't go on to be showing any activity at all. All of them are dead. This is what we meant by the previous animation. That is, that was where the hotspot was. Hotspot had remained, or the mantle plume has remained in this place. It's only that the Pacific plate was over it and it kept on moving northward. It kept on moving northward, and as it kept on moving northward, what it did was that it led to the evolution of certain type of volcanic activity on the surface. So, the present volcano, active volcano, goes on to lie here, and the previous one, that is the first volcanic activity that was evident in this place, that was going to be in this place. That was the place where the first one was going to be evident, and that was going to be existing. So, that went on to open its vent, and then a volcanic activity took place that manifested itself in the form of an island. Later on, that island got eroded and that sank. Then thereafter, this was the second one, and then. So, after this time here, the movement of the plate changed. So, instead of moving northward, the plate started moving northwestward, and that is going to be clearly evidently shown in this case, very evident in this case. Now, as we are going to be talking about it, this is where the chain of volcanic islands and geodes have been created by the hotspots, and that's where they are going to exist. That is the place. That also goes on to show the direction of plate movement, the movement of the plates, as well as any type of a change that may have taken place in the direction of the plates.